One portion of what we're doing today. You're only going to have 10 total problems at the end of the day. 5 over this section, 5 review problems. What we're going to be doing today is we're going to be taking equations and decomposing them. Not equations, really just complex things. Question. First off, what does decompose mean? Exactly. That's what we're going to be doing. First, who can tell me, if I wanted to get rid of these denominators, how do you get rid of denominators in a problem? Yeah, just multiply by every single one of those denominators, or if they have a common thing you can multiply by, you can just multiply. Like for instance, if I had, this is an example, 1/2, 1/3, 1/6, if you didn't notice that all three of those went into 6, you could multiply everything by both 2, 3, and 6. You could multiply by all three. But on this case, what could you multiply by that would kind of encompass all three of those? Yeah, 6. The top one, same difference. You are going to multiply by the common denominators. Now here's the point of what we're doing today. If you were to, the point of what we're doing is, this is what this problem started with. We are going to be taking things like this and decomposing them into smaller, simpler fractions. We're going to decompose complex fractions into simpler fractions. And that's what our goal is for the day. Now, what you just did was actually the math behind that. What you just did, here's what we're going to do. You have to factor the denominators today. When you factor this, it factors down into x and x minus 3 squared. Problem is, you can technically have 2x minus 3's, right? But you don't want the same denominator twice. So rather than put x minus 3, they changed this one and just put this thing originally. So you're going to decompose it like that. We'll look at many more examples. I know right now it's just by sound Chinese. And now, when we multiply by our denominators, look at what you get for this problem. We're going to multiply right here, and we're going to multiply that by x and x minus 3 twice. Let's just go and do it twice. That'll knock out this one and this one. So, when we multiply this by this side, the x's cancel, and you're left with a times x minus 3 squared. When you multiply by the second one of the x minus 3's canceled, and you're left with b times x minus 3. And when you multiply this by c, x minus 3 squared cancels, and you're left with cx. Now, after foiling and like terms and all that jazz, yes, that's probably going to be the hardest part today, is a lot of foiling. You're going to get a times x squared minus 6x plus 9 plus b times x squared minus 3x plus cx. Now, if you distribute, you get ax squared minus 6ax plus 9 plus 9a, thank you. Plus bx squared. I'm just going straight across, doing a bunch of multiplying. Now, here's where we're interested. Thank you. What all x squareds do I have? That's right, you have an ax squared and a bx squared. So I can really say, if I were to put my x squareds together, that's ax squared plus bx squared. What all just normal x's do I have? I have negative 6a and negative 3b, right? Oh, and c at the end. See how I just put all my x's together? What do I have without an x? 9a, and that's it, right? That is where your DOM came from, and this is the kind of thing you're going to have to do today. And I'll be showing you more examples. You are going to break this fraction down, multiply through by your common denominator, get to this step, and then you're going to pair up x squared, x's, non-numbers. This is exactly what you just did for your DOM. Let me go back. First thing. Oh, sure poopy. Okay. Well, I forgot to pull one thing out of here. That would have made more sense. But, okay. Equals I just accidentally lost the left-hand side. X minus 18. Sorry, I forgot to bring that down. Everything over here. Because when you multiply this by this, everything cancels. Okay. So, this is how many x squared, where am I? There we go. This is how many x squareds there were. How many x squareds were on our other side? None. So we put a plus b equal to 0 from the dom. This is how many x's there were. How many x's are left here? 1. So we put negative 6a minus 3b plus c equal to 1. How many just numbers were there? Yeah, negative 18. So we put 9a equal to negative 18, and solve. Now when you're done with that, all you have to do is backtrack to this step and plug those in. So what we say the answer was 2, negative 2, and negative 5. And here you go. You plug them back in and you're done. You have decomposed this by doing this into that. That's what we're doing today. You only have 5 of them, but we are going to look at a few more. Actually, that's not true. You've only got 3 of them because the first 2 just want you to do this. The first 2 just want this step. They just want to see, do you understand how the bottom would factor? And sometimes the factoring is already done for you. Let's look at our first set of examples. Here. All you have to do is break it down by the factors. So like number 1 is really staring us in the face. What are the factors of the denominator? X minus 2 and x plus 1. So all you need to do is put 11x minus 10 over x minus 2x plus 1, just the original, and set that equal to a over one of the factors plus b over another one of the factors. All I did was say that this I could break down into separate fractions, and I put a over one of them and b over the other. Nope. As long as you plug them back into the correct place later on. All right. Krista, what does number 3 factor down into? Just the bottom. Excellent. Excellent. And just like the last one, remember, see there's 2 of them. We can't just write it again. So, you remember what we did on the problem we just had on the board? I'm sorry? Yeah, you do the same thing, but actually square it this time. Because this is technically, this thing factored to be x plus 2, x minus 3, x minus 3, right? But having 2x minus 3s kind of throws everything off, because we could have just combined that by common denominator. So we need a third one to represent that, so we just write the whole thing again. It'll end up canceling out later on. All right, what about number 5? Melissa, what's number 5 going to factor into? Oh, I'm sorry. Okay. Okay. Yeah, that part doesn't factor. Now, I will say this, though. You see how this, before, there's an x squared actually in the term. It's different than this. This whole thing was squared. But see how there's an x squared actually in the term? When that happens, here's how you have to do it. When you actually have an x squared in there, you're just going to put bx plus c because there's 2 separate terms there. It's different when it's like this. I can't really explain why this is this. But when you have an x squared, then you need bx plus c in the top. What do you think it would be? Say it one more time. That's right. But there's 2 of them, so that'll be over x squared plus 4, and then cx plus d over the second one. But remember, since we can't just have the same thing twice, we're going to square it this time. That's all you have to do for the first ones. Notice how they factor and set these up. The next ones you have to do, which you will have 3 of, is where we actually are going to solve them. And I'll be working through 1 or 2 of those with you as well. Yes, sir. You only do x plus another letter when there's an actual square in the term. Yes. Now I know you see a square here, but it's not directly attached to the x, and you don't bother for them. Whenever there's a square directly attached to the x, you do the x plus whatever. All right, let's look at some. All right, now let's get down to it. Let's start with an easy one, then we'll do a hard one, and then hopefully we'll have appeased everybody. Okay, let's just start with number 9. Number 9, first things first, we're going to do exactly what we just did on the last few problems. Ben, how's that thing going to factor? Excellent. Excellent. Very, very good. Now, what's my common denominator all the way through my equation? 6. It's a combination of the individual factors. Essentially, it's just both of them together. Yes. Here's the thing. All of them today are going to be some kind of binomial like this. You see that? So when in doubt, just multiply by all of them. X minus 2 and x minus 3. Of course, here's an easier way to do it. Essentially, just multiply by the entire original, because that's what you factored. So if I multiply this by all the way across, first off, let's start on the left. But if I multiply this times this, both are going to cancel. And you're left with x. If I multiply this times this piece, which piece cancels? X minus 3, leaving you with a times x minus 2. If I multiply this times this one, what cancels? That's right, the x minus 2 cancels, you're left with b times x minus 3. Now we distribute. So that's ax minus 2a plus bx minus 3b. So we just need to put our pieces together. That's, if I factor out an x, that's a plus b. See how I have a positive a, positive b. You know what? Let me put it like this, make it a little easier for some people to follow. Ax plus bx, I'm just going to write them with their like kind. Minus 2a minus 3b. Now, what can I factor out of the first two? An x. Nothing factors out of the second one. So, it's just minus 2a minus 3b. Alright. Now, how many x's? So, a plus b equals whatever the coefficient for the x was over here, which is what? 1. That's right, there's 1x. How many numbers are there without an x? 0. So, negative 2a minus 3b equals 0. What? Just that step? Sure. I know this is not how the problem was, but let's say for a second that the original problem was like 2 plus 3x. I'm going to change it back to this second. So I know that a plus b, if these two things are indeed equal, and these are the two pieces being multiplied by x, a plus b would have to equal 3. Of course, our original one was just x, so what's the coefficient there? 1. I also know that everything without an x, just the number, has to equal whatever this would be. Now, if it had been this one, it would have been negative 2a minus 3b has to equal 2. But ours didn't have anything. It was just this, which is why we put 0. There was no number, so they have to equal out to 0. Here's our original. That's where that step comes from. You set it equal to the numerator. Essentially, this is just a numerator from where you started, and that's what it'll always be. And that's what you set this equal to and put the like terms together. Now, system of equations. Who remembers how to do that from a long, long time ago? Hey, all right. That's right. Elimination method. Multiply the top by 3. That'll give us 3a plus 3b equals 3. What did that give us? A equals 3? Awesome. So a equals 3. So if I plug that back in here, 3 plus what equals 1? Negative 2. So I come back up here and plug those in. And here's my finished product. 3 over x minus 3 plus negative 2 over x minus 2. And this is my final decomposed fraction. So I'm only giving you 3 of them. 3. Less than 4. Right here. This is your finished product answer. All right. Let's look at one hard one. Yeah. Good energy. You guys are dead. It's a Monday after prom week. No, that was the easy one. Because only thing we went up to was X. So, all right. Let's look at a fun one. Oh, just kidding. Energy level is tremendous. Right. Here we go. I'll take it. Whatever. Okay. Here we go. Chris, how does my bottom factor in this one? No. Just tell me how the bottom factors first. What factors out first? X, which leaves you with what? X squared minus 1? What factors from there? In the chance that you didn't see that this factored further, you could just do A over this plus BX plus C over this. But I think it'd be easier if you just went ahead and broke this down into X plus 1, X minus 1, and gave it its own B and C. Either way would work, but let's just go ahead and factor this down to X plus 1. Actually, you know what? For the sake of practice, let's do one like we had been setting up before. A over X, let's assume we didn't see the second factoring. So plus BX plus C over X squared minus 1. But either one would have worked if I had just made another one. B over X plus 1 plus C over X minus 1. You wouldn't have needed the X up here, but since we stopped there. Okay, now, just like in every single step, you're going to multiply by both of these, which is essentially multiplying by the original denominator if you did it correctly. So we're multiplying all the way across by X and X squared minus 1. If you do it correctly, you can pretty much just save yourself the math. Assuming you did it correctly, you can always just basically cancel off the first denominator, leaving you with 4x squared minus 7x minus 3 equals. What cancels in this one? Okay. I'll unpause. So I take this, multiply it by here, and the x cancels, leaving you with a times x squared minus 1. Then I multiply this by this term, and what cancels now? Times x. That's right. Because the x squared minus 1's canceled. We just multiplied both those terms by everything. Now, when I distribute on the right, what does that become? Keep going, Allie. Excellent. The only like terms are what? No, it'd be bx squared. Bx times x. Now, what are the only like terms we have? That's right. So, what's that? Positive a, positive b. Oops. Didn't mean to do that. Erase. So, that's x. Crikey. That is a plus b. What x's do I have? Just C. Yeah. And the only thing without an x. Okay, so first off, on the right side, what are my x squared terms? A plus b. What does that equal on the other side? Excellent. Yes. What does C need to equal? That's right. So that's easy. It just gave it to us. And what does A need to equal? Oh, excuse me. Negative A equals negative 3. So we're pretty much almost done with this one. What? A plus B is the coefficient for the x squared, right? So that has to equal the 4. Exactly. That's what we're solving for. A, B, and C are just numbers, coefficients. Yes, it is. Okay, so what is A? Positive 3. I'm just going to go ahead and plug that back in up here. What is C? Negative 7. I'm going to go and plug that back in up here. Technically, it's not fully decomposed because we didn't factor this, but whatever. And B, if I plugged this into here, let's see, that'd be A minus 3 equals 4, add 3, and what is B? Positive 7. And there you go. Although it's not fully decomposed, this is a decomposed somewhat. You're right. I put in -3, which should make this +3, which would make that 1. You all were correct. Kudos. You are. You really are. And we'd be done right there. Yay! I'm glad you thought so. So, we're done. I can tell you guys enjoyed that. Here you go, 10 problems. There they be. Only 3 of those. The first 2 were just oh, come on.